Hello, IB11s. The topic today is 2h, the modulus function. What is a modulus? The modulus is another word for the absolute value. So the modulus function is also called the absolute value function. The modulus of x is, okay, let's look at what is the modulus of 5. We know these two slashes always can make any number to be positive. So the modulus, or we can see the absolute value of 5 is 5. The modulus of negative 5, or we can say the absolute value of negative 5 is still 5. So the modulus of x is x if the x value is positive or 0, like this number 5 here. But if the inside number is a negative value, negative 5 for example, if we remove the absolute value symbol, we need to put a negative sign to show this is a positive number, because like this one, when we take off the absolute value, we need to put a negative sign outside the negative 5. So negative 5 becomes positive 5. The basic modulus function is y equals the absolute value of x, and you will find that, okay, just as what we did here, when x is greater than or equal to 0, this absolute value of x is just x. When x is negative, the modulus of x is negative of x. If I want to graph this one, you will find, okay, in this function, without the absolute value symbol anymore, you have two pieces. So this kind of function is also called piecewise function. So if I want to graph this modulus of x, I graph these two pieces of the functions. The first piece is y equals x. We know y equals x is a straight line. This is y equals x. The y-intercept is 0, the slope is 1. However, we don't need the entire line. We only need x is greater than or equal to 0 part. So what I will do is erase the negative x value part. For x is negative value, the function is y equals negative x. If I graph y equals negative x, this graph pass through the origin because the y-intercept is 0 and the slope is negative 1. It should be such a straight line. However, right now we have the restricted domain. We only need this line on x less than 0. So what I will do is I erase this part. This V shape is the graph for this modulus function. Of course, this function is also called a modulus function. And it looks like a V shape. Number 4, let's look at a very important property of absolute value of x. The absolute value of x is always the square root of x squared. Let's look at the first example. The absolute value of 9 is equal to the square root of 9 squared. The square root of 9 squared is the square root of 81. The square root of 81, of course, it's 9. So the modulus of 9 is 9. The modulus of negative 3. This one equals the square root of -3 squared. -3 bracket squared is 9. So it's the same as the square root of 9. Root 9 is just 3. So we will know the modulus of -3 is 3. The modulus of 0 is equal to the square root of 0 squared. It's square root of 0. It's 0. So the absolute value of 0 is always 0. Okay, let's look at example 2. If I know A value is -3, B value is 4, find each value. So the first one, the absolute value of 2A minus B. What I need to do is just plug -3 in for A, 4 in for B. So the first one I will get, in the absolute value symbol, I replace this A with -3, and this B with 4. So in the absolute value symbol, or we can see in the modulus symbol, we can get -6 minus 4, which is -10 in modulus symbol. The modulus of -10 is +10. The absolute value of A squared minus the absolute value of -B. A value is -3. Let's plug in. Then squared minus 4. Plug in 4 for B. The absolute value of -3 is 3. Then I do squared. So you guys will see the absolute value, or we can see the modulus symbol, has the same priority as the pair of brackets. If I have the modulus symbol, I always simplify the modulus part first. Then I do exponents. Minus the absolute value of -4 is 4. So 3 squared minus 4 is 9 minus 4. This one is 5. The absolute value of A times B. A is -3. B is 4. -3 times 4 is -12. The absolute value of -12 is +12. Example 3. Write down the following functions without the modulus sign and graph each function. That means we need to get rid of the absolute value symbol. The first one, let's look at how can I remove these two vertical lines. I will use the modulus function definition here. I can change any modulus function to a piecewise function. So here, I will say if x is larger than or equal to 0, I can just remove the absolute value symbol on x. It will become x minus x. Let's simplify x minus x. It's 0. So the first piece is 0 when x is larger than or greater than equal to 0. The second piece is x is less than 0. When x is less than 0, when you want to remove these two vertical lines, you need to put a negative sign for x. So it's x minus -x. Simplify this red one. This one is negative becomes plus x. So it's x plus x, 2x, when x is less than 0. If I want to graph this modulus function, I just graph this piecewise function. So I graph each piece respectively. The first piece is when x is larger than or equal to 0, the y value is 0. The y value is 0. It's a horizontal line overlapping with the x-axis. But right now, the restricted domain is x should be positive or 0. So I only leave this part there. The second piece is y equals 2x. Let's graph y equals 2x. For this one, the y-intercept is 0. And the slope is 2. That means you go up 2, go right 1. If you guys want to scale both of these two axes, that would be great. But right now we only need to sketch it. Let's just estimate the positions. But I hope that maybe you can just scale on both of the axes with some important points. Anyway, the second point is here. Then I can graph the second piece. However, I don't need the whole green line. I only need axis less than 0 part. So what I will do is I erase the positive part. So the final graph is such a horizontal line plus such a oblique line. This is the graph for this modulus function. The same for b. If I want to take off the absolute value symbol, I need to follow what I did here. So first piece should be x is larger than or equal to 0. In this case, you can remove these two vertical lines right away. Leave x times x, which is x squared. So this is the first piece in the piecewise function. When x is less than 0, when you remove this symbol, it will be x times negative x. X times negative x, the second piece is negative x squared when x is less than 0. So right now, I graph each piece individually. The first piece, y equals x squared. It's a parabola function. But right now, you only need the positive part. So this is y equals x squared when x is larger than or equal to 0. And the other part is negative x squared. Negative x squared and x squared, these two parabolas have the opposite direction of opening. So this one opens down. So this one goes this way. So this one is y equals negative x squared, and you only need less than 0 part. So less than 0. You don't need the other part. Let's look at the number c. C is a little bit more challenging because I have two modulus signs in this function. If I have two absolute value signs in one function, I will use a number line to help myself find the boundary points. First, the boundary points comes from this one is 0. This one is 0. When x is 0, this is one boundary point. When x plus 3 is 0, x is negative 3. This is another boundary point. Then you will see negative 3 and 0. Divide the whole number line into 3 parts. So that means if I want to take off the absolute value symbols here, I need 3 pieces in the piecewise function. The first piece is x is less than negative 3. When x is less than negative 3, this one is negative. When you take off the absolute value of x, it becomes negative x. X plus 3 is also negative. So when you remove the modulus sign, you need to put a negative sign in front still. Negative becomes positive. So this one becomes negative x plus 3. Cancel these two x. So this one is 3. So the first piece, I will know that when x is less than negative 3, the y value is 3. Let's look at the second piece, which is this part. When x is between negative 3 and 0, you will see this x is still less than 0. So absolute value of x is negative x. But this part becomes positive. When you remove the absolute value symbol, you just put down x plus 3 only. Then let's expand the brackets and simplify it. So it's negative x minus 3. It's negative 2x minus 3. So the second piece is when x is between negative 3 and 0, the function is negative 2x minus 3. The last piece is x is greater than 0. If x is positive, you know this one absolute value of x should be just x. X plus 3 is still positive. So when you remove the modulus sign, you only have brackets x plus 3. Then simplify this expression. It's x minus 3. It's negative 3. Which means the third piece in this piecewise function is when x is larger than 0, it's negative 3. In the domain, which is the real number system for this function, we still missed two values. One is negative 3, the other is 0. This is a kind of global rule. In most cases, we put the negative 3 value with this symbol. That means x is larger than negative 3. We always put it with the larger than sign. So when x equals 0, I put the 0 with this case. Okay, so right now I have all three pieces done. What I need to do is graph each piece individually. The first piece is y equals 3. Y equals 3. 1, 2, 3. It's a horizontal line. But you don't need to continue anymore. Oh, actually, we only need the part less than negative 3. So here, negative 1, negative 2, negative 3. So that's all what you need. Then the next part is between negative 3 and 0. The graph is negative 2x minus 3. This is a linear function. If I scale the negative x-axis as well, the negative y-axis here, it's negative 1, negative 2, negative 3. The y-intercept is negative 3. And the slope is negative 2. That means down to right 1. But you also can do up to left 1. So you will find this line look like this one. So this is the graph for the second piece. And the last piece, which is x is greater than or equal to 0. So this one, the graph is a horizontal line again. Okay. So it's look like a Z shape. So this is the graph for this function.